Hello, we are the LoRa Wireless Integration Group in the 2024 ECE Senior Design course. The sponsor for our project was Poseidon Systems. Poseidon is a company that specializes in real-time fluid diagnostic technologies. Our faculty advisor was Dr. Issah Ibrahim. Dr. Ibrahim is an associate professor in the ECE department here at Penn State Behrend. Poseidon Systems was seeking to modify the design of one of their existing oil sensors. They tasked us with designing a new oil sensor that uses a long-range, low-power form of wireless communication to send data to a remote interface. The reason for this is that wires are restrictive and they reduce the number of applications that a sensor can be used in. The current version of their oil sensor uses industrial Bluetooth, which lacks the desired transmission range that Poseidon is looking for. The sensor also needs to be power efficient so that the battery life is as long as possible. Poseidon also needs the newly designed sensor to maintain the connection points of the existing sensor.
For our solution, we're using a LoRaWAN network for our wireless communication. Like I said before, it's a long-range, low-power transmission, which checks our box for also allowing us to use our battery for as long as possible. We're using a STM32WL chip for its integrated LoRa radio transceiver and a lower power sleep mode to ensure that the battery lasts as long as possible. For system components, on our EndNode sensor side, our platform is based on the Poseidon Systems LH2500 sensor. This is an oil level and quality sensor, and on top of it, in the top left, we have our manufactured PCB, which has a STM32WL55CU6 chip on it, which acts as our microcontroller and radio for our project. And on top of all that to power is our iAlert 3 battery pack. On the gateway side, we have our ST LoRaWAN gateway, which acts as our receiver and collector for data, and that sends our data over a network link to our Laureate network server, which hosts all of our information.
This is a demo of our project running. We are using a development board in place of our manufactured board for this demo. On the right, we have the oil sensor connected to our development board. On the computer screen, we have the program running and a serial monitor to track the LoRa functionality. Currently, we have our system sampling and sending data from the oil sensor every 20 seconds, but this interval will be increased later to decrease power consumption. Here are some screenshots of our network server. The top image shows the status of our gateways and EndNode. The bottom image shows information about what our system is sending to the network server.
Thank you for watching.